Okay, in today's lecture we are going to see the next lecture that is related with switches. Now switches, these are the devices, networking devices, which are the enhanced version of hub or repeater or bridges, right? uh, we have already seen that at layer 1, that is at physical layer, the repeaters or passive hubs are utilized. Active hubs are utilized at physical layer, and if the filtering facility is added to that one, and that MAC addresses are read, then in that case that is called as a bridge. So it is working at data link layer. Now the switch is having a enhanced capability, so it works on a packet based. So a switch is a data link layer networking device and a network layer device, so it may work depending on whether it is a layer 2 or layer 3 switch. So depending on that we will divide it into layer 2 or layer 3 switch, but let us call it as a data link layer networking device which connects the device in a network and uses a packet switching instead of frame, packet switching to send and receive the data over the network. So we know that at network layer we will be using the packet switching. So this switch works at a layer 2 and layer 3. So like hub, switch has only has many ports, as well as you can plug the computers to this switch. When data frame arrives at a port of a network switch, it examines the destination address and sending address, and accordingly it will divert the packet to the destination. It supports both unicast and multicast communication. Unicast means one to one and multicast means one to many communication. So this is how exactly the switch looks like. So this is a switch which is at a central place. To this all the devices are connected. This is the sender and all these are the receivers, but these are the specific receivers where you need to find out where you want to send the packet. So that address is read, and to that receiver only this switch is transferring the data. So depending on that we can classify the switch into 2-layer switch and 3-layer switch. So 2-layer switch means we may call it as a bridge also. So this 2-layer switch are of two types, store and forward switch, and second one is cut through switch. Store and forward means it first stores and it forwards it accepts the frame at the input line, it buffers it, it stores it, and then it routes to the appropriate output line. So the bridge is also doing the same thing. And cut through switch means it cuts the frame into two parts. First one is it will try to identify the header part and then the data part. Header part, it will try to recover the address immediately so that it can communicate a fast communication between the source and the destination. So this type of switch is called as a cut through switch. So it will cut the whole frame into two parts, header and the remaining part. So header, it will read it immediately and it will try to find out what is the source and destination, and accordingly it will send the data to the destination. So layer 2 switch can be viewed as a full duplex version of a hub. That means it can receive as well as it can send the data, and it can also works on the logic of multi-port bridge. So I'll simply call it as so bridge is a 2-port device we have already seen, but here it is a switch, we can call it as a 2-layer multi-port bridge. So this is a 2-layer switch, and 3-layer switch is a switch where the number of layers in the schemes of the market, but fundamentally they fall in two categories, where you will be sending the data by packet or a flow based. So the switch on the basis of transmission of your packets, whether it is flood based or whether it is a packet to packet by packet, you can again classify this 3-layer switch into two categories. packet by packet and flow based. So packet by packet switch operates on a identical fashion just like a traditional router. That means whenever the packet comes in, it will try to find out the IP address of that one, because it is working at the layer 3 network layer. It will try to find out the IP layer, and IP layer it will find out in the routing table, and accordingly the destination has been decided and the packet is routed to that destination. So this is just like a traditional router. And flow based router tries to enhance the performance by identifying the flows of IP address, and it will try to adjust your data accordingly. That means it will try to manage the flow between the source and the destination. So incoming flow and outgoing flow, it will try to manage it, so it is called as a flow based. So the performance get enhanced because of that one, so collision will be less. So in previous case, two layer switch, collision cannot be detected, but here you can detect the collisions. So CSMA type of package, CSMA CA, CSMA CD, that type of protocols are supported by this kind of switch. So here it is the configuration, how you can configure your PC or your LAN with a switch. So here you can see that here within a LAN, these two devices. So this is a first case where this device and this device will get added to the layer 2 type of device. That means here you don't require a layer 3 because this is within a network. So this is LAN 1, you can call it as a, this is a LAN 2 where you can connect it to the layer 2 switch, layer 2 type of switch. Again, this is the third one where you can connect the servers to layer 2 type of switch. So again, these two layer 2 type of server switches are connected to layer 3 type of switches, and this layer 2 type of switch and this layer 2 type of switch which are having a higher speed, which will be get connected to the layer 3 switch, and through router it gets connected to the WAN. So this is how you can connect the various types of networks, huge networks together, and you can connect with layer 2 type of switch or layer 3 type of switch. So this is how a configuration can be done with the help of switches. Then what are the advantages of switches? So switch divide the network into several isolated channel as the collision is detected. So if the link is busy, then it will not follow, it will not transmit the data on that link, and so it will isolate that network. So such kind of isolation is possible in the switch. It reduces the possibility of the collision. So as I said earlier, so it will isolate the busy links or where the collision has detected. So because of that, again the possibility of the collision will get reduced. Then each channel has its own network capacity. So the you can get the example is here. The example is of video conferencing. The channel has its own capacity. The network channel is having its own capacity. If you are only transmitting the text data, it is having a separate capacity. So for that purpose, you can try to understand the concept like broadband ISDN type of concepts, where the channel is having is handling different type of medias, and these different type of medias can be transmitted over different types of capacities, and they have their own capacities. And since it is isolated, we can call it as a secured one. So this is the advantage. That means collision gets reduced, the channel can be set to its own capacity, and it can be a secured one. Then there are certain limitations of the switches. So what are those limitations? It cannot detect the collision if the buffer is full. So as I said, the switches are of store and forward type of switch. Then in that case, if the buffer is full, then in that case it will be very difficult to detect the collision. Then some higher level protocols do not detect the errors. So if you are using it with EDP, then it is difficult to identify the errors. If it is with TCP/IP, then the TCP/IP will itself will take care of these errors. Those data packets are continuously pumped to the switch and introduce more problems, so the efficiency will get decreased because of this one. So these are the limitations of the switches. So what is the difference between hub and switch? Now we know that hub and switch both looks like a same one. How we are going to identify it? So hub works at a physical layer, so at which layer it works, so we can decide the switch will work at data link layer or a third layer, or that is a network layer. Then hub is a non-intelligent device, whereas a switch is an intelligent device. Hub simply broadcasts the message, whereas switch supports unicast, multicast and broadcast. All the three types of casting is possible. Hub is a half duplex, that means one-way communication is there at a time, whereas switch is having a full duplex, that means simultaneously communication will take place between sender and receiver. The collision may not be detected at the time in hub, and the switch will avoid the collision, so the performance of the switch is better than the hub. So this is a passive device, whereas the switch is an active device. Only you can have a 4 or 12 bit or 16 bit or 24 bit of hub is there. Now that hub is get converted into switch, so we can call it as a 24 port or 48 port switches are available. So these are the basic differences between the hub and the switch. So on the basis of layer, on the basis of intelligence, on the basis of casting the message, on the basis of mode of the message, on the basis of collision, on the basis of passive or active, on the basis of number of ports, you can easily classify the hub and switch. Then the next device is router. This is again a 3-layer switch, but having little more intelligence. We will call it as a router. So router is a device, it's just like a switch that routes the data packets on the basis of their IP addresses, whereas switch is working with the MAC address is considered. Here will be routers will be considering the IP address. So it is a network layer device. Router are normally connect the LAN and WAN together and have the dynamically updating routing tables. So we will call it as a smart routers. So it will dynamically update the routing table based on the decision making algorithms or based on the algorithms for which it is designed and the routing of the packets. So we have already gone through the routing algorithms. So these routing algorithms are utilized over here. So if the 3-layer switch, it is a 3-layer switch which is a faster and more sophisticated than the switch we have seen. How the router works, we can see that whenever you send the data through the internet, for example, whenever you are trying to receive the information from the Google page or from the web page or an email, it is sent in the form of packets. That means from application layer it will be sent segmented data will be formed into packets, and packet will be formed into frames, and the frames will be formed in the format of 1 and 0, and this data is sent. But at network layer it is formed in the form of packets. So these packets typically forwarded from one router to other router through the networks that constitute the internetwork. We have already seen the definition in previous lecture. What do you mean by internetwork? So these packets are sent from one router to another router until it reaches to the destination node. So router is connected to 2 or more lines with a different IP network. So we have already studied how the IP or subnets are designed and how the IP addresses are assigned. Then this router will help you to route or to connect different networks having different IP addresses, right? So when a packet comes in from one line, the router reads the network address information in the packet header and determines the ultimate destination. So we have already seen the distance vector and the link state type of router algorithms, and from that we know that how the IP address gets updated in a table. So this table gets updated because of such kind of, so this IP addresses is read when the packet arrives at a router. So this IP address is read and accordingly it goes through the routing table, and this information is used to find out where whether this packet is from this routing table or not, and what is the routing policy adopted by that router. Depending on that, it will be sent to the next network or the next destination accordingly. So this is how a device can be connected. So this is one network. This is one sub network. This is another sub network which will get connected to the bridge. So here it is, which will get connected to the bridge, and these two networks are connected to the hub, and this hub is connected to the switch. Directly you can connect this device to the switch also, that is quite possible, but just try to understand how we are connecting the devices. So this is connected to the hub, so this is a internal hub or internal switch, you may call it as a. So this is hub A will act as an internal switch, and this is a internal switch to this LAN. This is internal switch. Switch 1 is the internal switch to this LAN. So this LAN will get connected to this switch, which will call it as a layer 3 switch or router, which is an external one, and this external is get connected with this switch 2, and this is how a network 2 will get connected to this one. So this is how you are connecting the two switches together, or two LANs or WANs together. LAN is connected to WAN. So simply I can connect here it one more WAN can be connected over here. So this WAN can be also get connected to this device through the router. So this is how the connection is possible with router. Okay, so router may have interfaces for different types of physical connections. So you can connect, it will be a wired communication, it will be a fiber optic communication, or it will be a wireless communication. So you just see around you, so whatever may be the Wi-Fi you are getting, or if you go to the multiplex or if you go to the railway station, then you will be getting a Wi-Fi connection, but these Wi-Fi connections are connected to the main device, what we call it as a gateway most of the time. So to that gateway these routers are connected, and through that router you will be getting a wired or wireless communication. So most of the times you call it as a Wi-Fi. So router may also be used to connect two or more logical groups of computer devices known as subnets. So logical groups we have already covered, so we have already seen that, and this will have a network prefix. So the network prefix we have decided with the help of slash number of bits. So this network prefix will decide the subnet, and this subnet is a logical group, and these logical groups can be connected to the routers also. So for that purpose also router can be used. So router may include, so this is a smart router or intelligent router, which will give you the secured environment, so that you can be at a secured level. You can protect your information from the external intruders, or from hacking of the data. So firewall will be there, then VPN, that is a virtual private network handling technique, will be there, or any other security functions that may be added to the routers. So these routers are, we may call it as a smart routers. So these are able to handle the devices separately devices. Instead of that, all these separate security devices are incorporated in the router. That's why I'll call it as a smart router or intelligent router. So what are the functions of router? So it is used to connect multiple networks and forward the packets to the destined, either for directly attached network or more remote networks. That means if it is directly connected, it will be direct, only one router will be required. If it is remotely, then you'll be requiring more routers. So router to router packet forwarding is also there. So router also has to manage the congestion when the packet arrives at a higher rate than the router can process. So this is one of the facility available, or this is one of the function. So it congestion control is another function of the router. It will decide to whom the packet should be processed when the multiple queues are existing, and it will be managed through the quality of service management protocols. Then a policy based routing is another function of the router, where you will be requiring a special rule that are constructed to override the rules derived from routing table when the packet forwarding decision has to be made. So whenever you have to decide it, so this policy based routing, it will decide to whom you should send the packet. Now again, on the basis of the type of routing table you are updating, again we can classify the router into two parts, the static router and dynamic router. So mostly nowadays we'll be using the dynamic routers, but you need to understand what do you mean by static router and dynamic router. So static IP address and dynamic IP address, that we have already seen. Then static routing and dynamic routing, that also we have already seen. So the device which will be using the routers when you are manually configuring it, the routes, then we will call it as a static. And the manual configuration of the first route you have to decide, and thereafter it will automatically update the routes, update the routing table, we will call it as a dynamic router. Then always use the same route. So once the table is fixed, in case of static router, you have to follow that route only. But in dynamic router, it will select the best route. It will select the best route. And static routers, it is more secure, and dynamic router you need to manually configure for the security improvement. So these are the differences of static and dynamic routers. This is how you can divide the two on the basis of the way you are updating your table of the router. Now the next device is called as a gateway. The next device is called as gateway. So gateway, it is, the name suggests that it is a passage that connects the two networks together that may work upon the different networking models. Now this is very easy to understand. Gateway, that means a passage. Now whenever you are moving from one area to other area, whether these two areas are same? No. So whenever you are crossing the boundaries from one nation to other nation, then you have to go through the immigration process. So this immigration process you have to do it at your nation also, and whenever you enter in that nation, at that nation also you have to process this information. So this is nothing but a gateway process. That means you are moving from one network to another network. So the device which will connect such kind of networks, we will call it as a gateway. So this is one definition. So basically it works as a messenger agent that takes the data from one system, interpret it and transfer it for the other system. So the best example is, if you are able to understand the languages of both the countries, then it's okay. But if you don't understand, you will be requiring interpreter. So when the two networks of different topologies having different protocols are there and they want to communicate with each other, then at that time you will be requiring the devices called as a gateway. So this gateway will take care of that one. It will take the information from one system, it will interpret it and it will transfer to the other system, even though they are working on a different topologies or they are having a different protocols. But the gateway will make sure that they will communicate with each other. So gateways are called as a protocol converters, and it will operate at any network layer. So it is basically, we know that in OSI model there are 7 layers. So this gateway will work on all the 7 layers. So gateways are generally more complex than a switch or a router, because switch and the router, they will work at layer 2 and layer 3 only, but at higher levels, so the complexity increases. So this gateway will be helpful for that purpose. So it can operate at any 7 layers of the open system interconnection model, that is OSI model. So this is how you can see that. So this is the 7-layer model. I can see that this is a 7-layer model for this A device, and A device is having, let us say, a ring topology. A device is having a ring topology, and this is having, say, a star topology or tree topology. Okay, and this will be obviously working on a token ring type of protocol. Okay, and here it will be working on Ethernet. Obviously both are different. IEEE we have already seen, this is Ethernet. Okay, well, and we have already seen that both are totally different. So this may be working on 802.4 and 802.5, or this may be working on 802.3. So 2.3 standard is different from this token ring standard. So obviously the protocols developed for these two devices will be totally different, but still they are able to communicate with each other because of this gateway. Okay, so the term gateway is to reference a device which enables user to access the application. So we know that the application will be at this layer. The application will be at this layer. So whatever may be the device, applications like email, applications like browsers, these applications are utilized over here in this application layer. So these applications are able to communicate with each other, and this gateway will enable you to communicate with each other. So it has not only ability to translate between the frame format, but also between the different protocols. So this is very important. So the frame format for this one is different, and the frame format for this one is different, but still they are able to communicate with each other. So generally a gateway is used to connect huge and incompatible networks. Incompatible means both are totally different networks. So we are able to connect these networks together, and the gateway will help us to connect with each other. Okay, so this is how you can connect the device. This is how you can connect the communication between each other. You can see that here it is a packet network, where you may call it as a separate LAN or WAN or a separate server. So here you can see that it is a separate server. IBM mainframe is a separate server. So to that, this adapter is connected, and to this a gate is connected, and to the gateway again a modem is connected. This modem is connected to the remote modem where this packet network is there, and this is connected to the LAN, and through this you can access this remotely based network as well as this IBM frame. And because IBM, they have their own system, they have their own networking protocols, and this packet network may have their own protocols, but still you are able to communicate with each other, and this is only possible because of the device called as a gateway. This is how you can interconnect the IBM frame or the remotely based networks to your LAN through the gateway. So with that